Good day, Year 11, and welcome to our unit on Earth geometry. In this unit, we'll be looking at where you locate yourself on the Earth and how to find the distances between two places. We're going to be looking at different speeds and times of arrival and time zones and so on. So we're going to be using our Year 11 textbook, and we're going to use the first half of a Year 12 book with the first half of chapter 5. Before we start, this unit is quite helpful in just locating yourself on the Earth, and it gives you a good sense of directions. Can I get you to work on the skills check? That's on page 215, and then we'll proceed with the lesson. Okay, so the first lesson is going to be latitude and longitude. Now, latitude and longitude are the ways that we locate our place on the surface of the Earth. They are imaginary lines, and they're there for our purpose. A great circle is the biggest circumference of a sphere. So obviously you can make smaller circumferences of a sphere if your radius does not go to the center of the sphere. So this first idea I want to cover with you is just to revise how to find the circumference or the length of a great circle of a sphere with a radius of 50 centimeters. So remember, our knowns are the radius, and we want to find the circumference. That's our unknown. Now we know that our formula to use is 2 pi r or pi d, because diameter is 2 radii. Okay, so we just substitute in circumference equals 2 times pi, and the radius is 50 centimeters. So our answer will then be 314 centimeters. So the circumference of a circle, or the circumference of the great circle, is going to be 314 centimeters of a sphere with a radius of 50 centimeters. So let's think about this terminology. When we think about the Earth, there are great circles and small circles. So a great circle is a circle drawn on a sphere that has the same center as the sphere. This is the largest circle that can be drawn on a sphere. A small circle is a circle drawn on a sphere with a different center from the spheres. So for example, this one here and this one here are going to be small circles because the radius will be in there. And so it won't go directly to the center of the sphere. Now a latitude is the distance north or south of the equator. So I mentioned before the equator was this circle here that goes around the center of the Earth, and north is above the equator and south is below the equator, and the lines that go across here are called latitudes. Now longitudes are the distance east or west of Greenwich in England, and that's it. Greenwich then is our prime meridian, or 0 degrees. Now if we think about this word meridian, our meridian are these lines that go up and down. They pass through the North Pole and the South Pole, and so all our meridians will be great circles. If we consider our parallels of latitude, now parallel means that they all run in a straight line and never touch each other. You can see that these are parallel to each other. Now I also remember that lat is flat. Now the only parallel of latitude which is a great circle, as I mentioned before, is the equator. And that's this one here. All the others are small circles. So if we want to get an idea around this, so here we have the center of the Earth, and this has got to be the greatest radius, and therefore we will get the greatest circumference. So that will be a great circle. Now this one here is going to be a small circle. It's going to be a latitude, and the center is not going to be reached by this radius here, and you can see what we're talking about here. So remember that lat is flat. Latitude goes flat. Now longitudes are going to be the longest circles, so they've got to be the bigger ones, and they go up and down. So we're going to read directions with the lat long convention, I suppose we call it. So if we'll have a look at A, so we need to say, where is this A, point A? So we read our longitude scale to find our latitude. So it's 30 degrees. Now it's above the equator, so it's got to be north. And then we have a look here and we read 20, 40, 60 degrees west. If I have a look at point B, I want to find this line of latitude, or the parallel of latitude. So 10, 20, 30, 40 degrees south. And then we'll have a look here, and we're on this line of longitude here. So that's 20 degrees west. Now, our sphere, or our globe, is made up of a couple of halves, the east half and the west half. So if I want to think about the east half, we have our prime meridian. It goes through Greenwich and London, and from here to here, so this is all east. And you can see 30, 60, 90, 120, 150 degrees east. So if I think about that, that's got to be the east side, and therefore the west side has got to be this side here. And so we have the Earth rotating, the sun will come up earliest in the morning in Fiji, then New Zealand, then Australia, before the rest of the world. The international date line is the opposite half to the prime meridian. So we have London here, and we can say, well, half the world is east of London and half the world is west of London. So we have a look at a map here. Let's have a look at a few examples here. So let's locate ourselves a few cities, and then I'll get you to have a go at some yourself. So what are the coordinates of Singapore? So first of all, let's locate ourselves where Singapore is. That looks to be that dot there. Now Singapore's directly on the equator. So that means it's 0 degrees north or south. You don't really need to write the north or south there, but I've written it there just to help remind us that we're talking about the latitude lines. So therefore we now need to estimate, using this here, maybe a little bit further over, how far in east of of London, how far east is Singapore. So we know it lies closer to 90 degrees east than it does to 120 degrees east. Now I would think that's about halfway there. So halfway between 90 and 120 is about 105. So let's call this about 100 degrees east. So 100 degrees east. Now I've read my latitude, then longitude. Now let's look at Bundaberg, good old Bundy. So we want to figure what latitude is it on. Now we see that the equator is here, so it's got to be south of the equator. Now I guesstimate that it's a little bit north of Brisbane, so let's estimate it to be there. Now we think halfway between this line and this line is 15. That's 15 east, but it's certainly closer to the 30 than it is to the 15. So let's say it's about 25 degrees south. So the coordinates of Bundaberg, let's say 25 degrees south. And let's see how far east it is then. So here's our east line. So it's a lot closer to 150 than it is 180. So let's think that halfway between 150 and 180 is got to be 165. I would estimate then it would be closer to 155 degrees east. 155 degrees east. So we have estimated the coordinates of two towns. Now let's do this in a reverse order. What city lies approximately 30 degrees south and then 30 degrees east? So let's go to 30 degrees south. So we're along this line here. And then we need to look at 30 degrees east. So here's 30 degrees east. And it looks like Johannesburg is the city that we're looking at. Can I get you to work on exercise 6A, and that's found on page 221. Thank you.